Question number 12 is about DMTF or dual tone multi-frequency signaling, a basis for the voice communication control, and today widely known in used in modern telephony to dial numbers and switchboard configuration. DMTF consists of two sinusoids or tones that has frequencies taken from two mutually exclusive groups. These frequencies are chosen to prevent harmonics from being incorrectly detected. So each frequency has a unique tone or sinusoids. So one group has a low group, then on this side, the high group is on this side. So as you can see here, it's a number dial pad wherein 12320 and hashtag and asterisk. Each number has a corresponding tone, which is this one from the low group and one from the high group. And for this question, to we are tasked to generate the MTF signals using symbols 5, 8, 3, and hashtag. So as you can see, the code is in here where we will ask for a number. Then for each number, there's a specific signal, sinusoidal signal being computed, wherein the FR as a value, which is the frequency for the row and column. Then asterisk is equated as Y start and Y cancel for the hashtag. For the 5, it will display this signal. For the 8 is this signal. For the 3 is this signal. And for the hashtag is this signal cancel. Hashtag is not a numeric number, so it is equated into another input, which is 12, and the asterisk is for 11. As you can see, it plots the Y cancel for the hashtag. To run this, running this section would be this graphs. To do the TFTF signals for 5, 8, 3, and hashtag, you would run this section. Then it will ask for an input number. First is 5. Then it will display a figure, the DMTF signal. So for input 5, that the signal, the MTF signal is looking this compressed, wherein over the time interval, the signal is compressed. Then to run again for the signal number 8, when press button 8, for example in a telephone, the signal it produces is this type of signal frequency, wherein it is also compressed. However, there is a pattern or variation where on the middle part there's a small compression at around zero point 0.5 to negative 5 amplitude, then the maximum of 1.5 to negative 1.5 to negative 1.5 amplitude per cycle of a signal, per cycle of the signal. Then if we run again this to get another type of signal, next one is the 3. When 3 is pressed on a telephone dial, then you would see this kind of signal, a signal that is loose, slightly loose in compression. However, there is a pattern wherein the First signal going down is has a change in amplitude over time. Then the rise, slight change in the amplitude, slight down. And you can see that the pattern here is inverted. The first signal is looking this one. Then this image of signal is repeated. However, it's going downwards where the maximum it reaches -2. Then after a cycle again, there is a change in the upwards wherein the maximum is +2. Then downwards, maximum of -2 after each cycle of the signal or the frequency. The last signal would be the hash, hashtag signal, and based on the plotting, it is 12. We input 12 since hashtag is not a number, it's a symbol, and it plots y cancel, and y cancel there is equals to hashtag. Running this section, we put 12 with the hashtag instead of hashtag symbol. As the graph, you can see the graph has a visible loosely pattern wherein there's a maximum of 2 at the middle part of the signal. At each cycle, it reaches a maximum downwards and upwards. It is visible already for the cancellation part. Now, if we try to put the hashtag, as you can see, input a number, there's it, the color is red, and if we enter it and it will not pick the number, it will ask again. So if we put 12 for the hashtag, it's going to show this type of signal frequency once more. A certain pattern for the frequency and the amplitude of it for the hashtag signal, hashtag number or button on a tone dial.